Good morning. Today, next going to the topic inverse is a transforms using partial fraction method. Already more and more methods are there. Now we have to see the Z transforms using partial fraction method. Inverse is a transform by using partial fraction method. The three types of partial fractions methods are there. One by one we have to see the three types of partial fractions method. First, find the inverse is a transform of z square plus z by z minus 1 into z square plus 1. Let f of z equal to z square plus z divided by z minus 1 into z square plus 1 equal to az by z minus 1 plus bz square plus cz divided by z square plus 1. Z square plus z equal to az into z square plus 1 plus bz square plus cz into z minus 1. Put z equal to 1 in the above equation. Why we have to put z equal to 1? We have to find out the constant value a, b and c. Any two constant value are 0, we have to find the remaining one constant value. Therefore we have to put z equal to 1. Substitute z equal to 1 square plus 1 2, 1 into 1 square plus 1 2a, 1 minus 1 equal to 0. Therefore bz square plus ez into 0, a into 1 plus 1 2, upper 2a, 2 equal to 2a, a equal to 1. Coefficient of z cube. Next we have to find the coefficient of z cube. A plus b equal to 0. Find out the coefficient of z cube. Left hand side is the no coefficients of z cube. Only z squared are there and z is there. No z cube are there. Therefore no coefficients. Therefore left hand side equal to 0. Right hand side is z into z squared plus 1 is there. A into z cube is there. Up a. Next b z square into z is there. B. A plus b equal to 0. A equal to 1. Substitute 1 plus b equal to 0. Therefore b equal to minus 1. Next, coefficient of z. Above equation we have to find the coefficient of z. Is left hand side is 1 and right hand side is a z into 1 a and c z into minus 1 is minus c. 1 equal to a minus c. 1 equal to, substitute the value of a, 1 equal to 1 minus c, 1 minus c, 1 equal to 0, therefore c equal to 0. Next substitute the value of a, b, c. F of z equal to z by z minus 1 minus z squared by z squared plus 1 and taking inverse z transform of f of z equal to z inverse of z by z minus 1 minus z inverse of z square by z square plus 1. 1 power n minus cos n pi by 2. 1 minus cos n pi by 2. This one is the first sum. Second one, find the inverse z transform of z cube by z minus 1 the whole square into z minus 2. Therefore let f of z equal to z cube by z minus 1 the whole square into z minus 2. F of z by z equal to z square divided by z minus 1 the whole square into z minus 2. A by z minus 1 plus b by z minus 1 the whole square plus c by z minus 2. Cross multiply this equation. Z cube by z minus 1 the whole squared into z minus 2 equal to a into z minus 1 into z minus 2 plus b into z minus 2 plus c into z minus 1 the whole square by z minus 1 the whole square into z minus 2. Z square equal to a into z minus 1 into z minus 2 plus b into z minus 2 plus c into z minus 1 the whole square. When z equal to 1 implies 1 equal to minus b, therefore b equal to minus 1. Next, when z equal to 2 implies 4 equal to c, then c equal to 4, therefore z equal to 0 implies 2a minus 2b plus c equal to 0. 2a plus 2 plus 4 equal to 0, therefore a equal to 2a equal to minus 6, a equal to minus 3. Substitute the value in the above equation. F of z by z equal to minus 3 by z minus 1, minus 1 by z minus 1 the whole square, 4 by z minus 2, z cube by z minus 1 the whole square into z minus 2, minus 3 into z by z minus 1 minus z by z minus 1 the whole square plus 4 into z by z minus 2, z inverse of z cube divided by z minus 1 whole square z minus 2 equal to minus 3 into minus 1 whole power n and minus n plus 4 into 2 power n, 4 into 2 power n minus n. These are the value 4 into 2 power n minus 3 minus n is the solution of this equation.